Okay, let's look at the trickier question 1 algebra questions. And I'm going to show you question 1.3 here. And here we've got it. We've got this 2 times 5 to the n minus 5 to the n plus 1 plus 5 to the n plus 2. Well, the first thing you got to do, you actually don't need this thing in the middle if you recognize what the common factor is, which is 5 to the n. It's in all three of these things. It makes it a little easier if you write it like this. 5 to the n plus 1 is 5 to the n times 5 to the 1. That's the first law of exponents. When you multiply two things of the same base, you can add the tops, but both of these are the same thing. So 5 to the n times 5 to the 2. Now you can really see that 5 to the n is being multiplied by all three things in here. So you just factor it out. 5 to the n times 2 gives me that. 5 to the n times minus 5 gives me this part. And 5 to the n times 5 squared, which is 25, gives me this part. Well, 2 minus 5 plus 25 is 22. 20 plus 2, 25 minus 5 plus 2, 22. Now the question is, show that if n is a positive integer, that this number's got to be even. Well, if n is a positive integer, like 1, 2, 3, or something like that, and a multiple of 5, you're going to end up with another integer. It must be a positive integer. And if you take a positive integer, no matter whether it's odd or even, and you multiply it by an even number, it's got to be even. So that's it. That's your answer. This is showing that 5 to the n times 22a. Maybe you have to make some kind of statement like this. I don't know. We'll have to wait for the memo. But here, let's try this one. Ooh, I thought this was a bit of a bear cat. I don't know, kind of hard. Well, there's different ways of doing it, okay? You're supposed to solve for x and y, given this thing here. So what are we going to do here? Let's try this. I did it one way. Actually, you know, this way over here on the right, when you go, okay, 32 is 2 to the 5th power, and 96 is 2 to the 5th times 3. Your calculator will tell you that. And it's both put to the x power. Well, the first thing you do is square both sides. So 2 to the 5th turns into 2 to the 5 times 2, 2 to the 10th. And I squared this top, so it's 3 to the 2y plus 2. And I squared a square root, so the square root's gone. Okay, now the whole thing with being able to solve an exponential equations is trying to make the base look the same. So what I'm going to do is divide both sides by 2 to the 5x. So multiply the bottom here by 2 to the 5x, and here, well, here it'll cancel, and you'll just get 1. But I'm going to write that in the bottom as 2 to the 0, so I can make the bases the same. And here I multiplied by 2 to the 5x. And, ooh, something special happens now. I've got 3 to the x on the top. Now I've got the bases the same. And I wrote this as 2 to the 0 so I could have the bases the same. Well, now I've got an equation. 10 plus 5x equals 0. I subtract 10, divide by 5. I get my answer. X equals minus 2. Now this 2y plus 2 must equal x. So all I do is replace x with minus 2. The only way these two things can be equal is if their exponents were equal. 3 over 2, 3 over 2. So their exponents have to be equal. So I put in minus 2 there and I solve. I get minus 4 divided by 2. I get y equals minus 2. And it's such a weird question. I actually put it in my calculator to check to see if I had the right answer. So I went 3. And when you square a square root, you should check here. You can end up with extraneous solutions. So it's good to check. So I put minus 2 plus, in my calculator, 3 to the minus 2 plus 1 over 32. I got 1 over 96. And the square root of 96 to the minus 2, I got 1 over 96. Well, that makes sense. I didn't need a calculator for that. There's other ways to do it. You can just take a look at this here. I just wrote this 96 as 30. I didn't have to put it into powers of primes, although that's a kind of a good way to go often, but it's a little bit easier if you just make it 32 times 3 is 96, and then square both sides, and then divide both sides by 32 to the x power. You get this. Hey, 2 plus x equals 0. Same thing. Hey, this is a little bit easier to look at using the base of 32 and 3. And then I played with it another time, and I said, well, maybe I can make anyways, I did it a little bit differently here, but it's just the same thing. It's the same thing, but I use the factors a little bit differently, 32 and 3. Now you can just pause the video and take a look at this solution, but you see I got the same answer. X is minus 2 and y is minus 2. And there you go. That's how that all works.